So for the next example, we have find the integral of dx over x squared minus ax squared, where a is not equal to 0. Now you can see clearly that where we have the dx, it simply tells you that the coefficient here is 1. So, and if it is 1, that means the degree of the numerator is not greater than the degree of the denominator. So the rules that we studied in the part 1, it says that if the degree of the numerator is bigger than the degree of the denominator, you have to divide. But if the degree of the numerator is less than the degree of the denominator, then go ahead and factorize the denominator. So because here the degree for the numerator is less than that of the denominator, that means we have to factorize this. And you can see clearly that this is difference of two squares, x squared minus a squared. When we expand this, we end up getting x minus a times x plus a. Okay, so it's as simple as that. So that is when you expand. Now once again, this is also a linear factor. So the first denominator should be given a numerator of a. That's how you see a over x minus a. So this x minus a is the first numerator here, denominator here. And then the second one will also be given a numerator of b. So we have b over x plus a. Now our business is to determine the values of a and b by making sure that you use the LCM on the left hand side to multiply everything. So the LCM is going to be x minus a into bracket x plus a. So this will multiply the left hand side. The same LCM will multiply this one, and the same LCM will multiply this one. So let's go. If this multiply itself, it means this one will cancel itself. So what we have left is 1. That's why when you come here, you see 1 here. Okay. Now let's also see if this LCM multiplies this, the x minus a will cancel x minus a. So meaning we are going to have a will now multiply x plus a, just like you are cross multiplying. So this will multiply this. So a multiplies x plus a, and then b multiplies x minus a. So we have it here, and then it's equal to 1. We have already explained how we got this one. When you multiply, this is the LCM. When you multiply the whole of this by this same thing, this will end up cancelling it. So you'll be left with 1. So now that we have done the expansion, let's now go ahead to determine the value of a and b. Okay, so to determine a, as we said earlier, you ask yourself, if I want to actually eliminate one of them, let's say I want to eliminate b from it, you ask yourself, what value of x will make this one 0? So if I put a here, okay, if I put a here, it becomes a minus a, that will be 0, and 0 times b will give us 0. So this one is gone. Remember, I said that wherever you see x, you put a there. That means here, in place of this x, we are going to put a. So a plus a will give us 2a. So this big A is what we see here. And then the a plus a giving us 2a is what we see here. And already a minus a is 0. So this one doesn't exist anymore. And it's equal to 1. So if you have a into bracket 2a is equal to 1, then all we are doing is to find the value of the big A. So we divide both sides by 2a. So divide here by 2a, divide here by 2a. That means the a is going to be 1 over 2a. So that is how come we got the a. Now remember, we are looking for both a and b. So now that we have determined the a, let's now find how to get the b. You ask yourself the same thing. So to get the b, you must first eliminate the a. by asking yourself what value of x when you place here will give you 0 here. So naturally, if I put negative a here, negative a plus positive a will give me 0. That means a will disappear. So when you come to the right hand side, we are saying that at x is equal to negative a. So obviously I place negative a here and this is 0. And when I put negative a in place of x, remember wherever you see x, you are putting negative a if you are looking for b. So if I place negative a here, neg a plus neg a will give us negative 2b. So negative 2a. So that's how we have minus 2a here. And then this b is still there. So this b is what we see. Now our target is to find the value of b. So what do? We have to divide both sides by minus 2a. So dividing both sides by minus 2a, we are getting b is equal to 1 over b is equal to negative 1 over 2a. Now we have determined the value of a and then the value of b. So what do? We have to now go back and then replace them into the partial fraction. So let's now move. Remember already that this was what we're having. When we actually break this one down, when we factorize the denominator, we got this. And now we know that the a is 1 over 2, 1 over 2a, and then the b is minus 1 over 2a. So wherever we see a, we are going to put 1 over 2a there. That is for the a. And then where we see b, we are going to put negative 1 over 2a. So when I come down here, you see the negative 1 over 2a. Okay, now that is as easy as that. So the next thing to do is that we want to actually integrate this. And it is very easy to integrate this. But then look at it. There's a common factor. What's the common factor? When you look at this side, you see 1 over 2a on this side. Then when you see this one side too, you also see 1 over 2a. That means it's a common factor. So before we introduce the integral sign, let's factorize the common symbol out. And so that's how come you see 1 over 2a coming out, because it is common to this and then common to this. And so once we have taken the 1 over 2a out, this is what we have. And so the foundation that we laid, given 1 over x minus a, to integrate this, you know it is going to give us straight away, we are going to actually have the natural log of the absolute value of x minus a. And then when you integrate this one too, is the same thing. You get, remember this negative is what we see here. So when I integrate 1 over x plus a, I'll get the natural log of absolute value x plus a. Okay, and then you close the brackets. But then we haven't finished. You remember in logarithm that there are rules that we need to understand. So let's get a pen and then see some logarithm rules here. Now you recall that in logarithm, if you actually have a divided by b, you know that this is talking about subtraction, right? Okay, so in order not to waste our time, now let's look at this. Let's look at this. This one, the final answer, 1 over 2a ln absolute value x minus a minus ln x plus b. Now here again, there is a common factor. What is it? We have natural log here, natural log here. It is common to this side and this side. So let's factorize it out. So by way of factorizing it out, this is what we get. So let's give a bit of explanation. So in log, natural log of x minus natural log of y, if you remember, is equal to natural log x over y. Why? It means you factorize the natural log outside, And in logarithm, negative always goes with division, and then addition goes with multiplication. And so let's apply this rule into this. So for 1 over 2a, we have it here, and then natural log being factorized, natural log here, and then we have natural log here. We need to factorize it out, so it come out, and this is what we have. And then once we are done, we now have absolute value x minus a minus x plus a. Using the principles of logarithm, it means minus deals with division. So we have x minus a on top, that's the first one on top, and then x plus b down, and then plus c. And this is how easy to use integration involving partial fraction with linear factor. Now the next episode we are going to deal with using repeated factors and then quadratic factors. Make sure you subscribe. My name is Darlin Fee.